Welcome to Young Tuition. This is a unique channel to explore, study, and share the knowledge about basic issues in physics and beyond. Today, I will continue discussing the implications of Ratafium's recent experiment. In my previous videos, I carelessly used a different time scale to analyze the experimental result. Obviously, there are some repercussions, but I can show you the main points discussed in the previous video remain valid. In addition, there are some good news for the viewer who are in the electronic engineering. Let's go to the blackboard. My topics today is a golden opportunity for an electronic engineer to get Nobel Prize in physics. Now I will going to tell you why and how. 4 months ago, a YouTuber called Alphaphonics did an experiment by using a 1 kilometer wire in which the time taken for the signal from the battery to the another side is 3.3 nanoseconds, while the time taken for electronic signal travel along the wire from the battery to the resistor is 1.67 microsecond. So that is an experimental result obtained by Alphaphonics 4 months ago. From here, you can see the duration of the first stage is exactly 1.6 microsecond. In addition, he did some very interesting tests by cutting the electrical wire on both ends. As a result, the detected voltage across the resistor drops after that characteristic time, namely 1.6 microsecond. And after several oscillations, eventually reached to 0. This is the experimental setup used by Ratafium recently. Notice that the half distance along the copper wire is 21 meters. Therefore, the time taken for the signal travel along the wire from the battery to the resistor is 70 nanoseconds, while the time taken for the electrical field directly propagate to the other side is the same, namely 3.3 nanoseconds. It's a very short time interval. So this is the result with correct time scale this time. From here, you can see that the 60-second nanosecond is a duration of the first stage voltage across the resistor, which is very close to the time taken for the light travel from the battery to the bulb via the copper wire. If I zoom into that detail, you can see that the time taken for light travel from one side to another is relatively short, as shown by this red-colored interval, 3.3 nanoseconds. Based on the current experimental setup, it is unlikely, almost impossible, to identify any faster than light process. That is why in my first video, I was careful. I say it might be, because obviously if that were so, then that would be a breakthrough in physics by detecting some faster than light process. The current situation is that the experimental setup or the instrument they used is not good enough to answer this fundamental question. If, however, someone can come with some better instrumentation and experimental setup, it is still likely some more detail can be observed. So this is a diagram I used to illustrate this possibility. From here, you can see at the moment, the time resolution and also the signal to noise of the signal are poor. Therefore, it is unlikely and almost impossible to make any observation in the time scale less than 3.3 nanosecond. However, if someone can come out with some better instrument, then it is possible to detect the signal in the sub-nanosecond, as shown in this diagram here. So this region is called faster than light region. So that is why I call this as a golden opportunity for electronic engineering to do the experiment. In addition, here are several proposed experimental methods for any person who wish to do this experiment further. First, I suggest that the distance between the two sides, called interdistance d, be used as a variable, because apparently the longer the separation and the longer the time taken for the photon travel from one side to another. Obviously, the larger the separation, the weak the detected voltage signal will be, because they cannot escape this inverse distance square law. Still, it's worthwhile. Another is simply using time average method to increase the time to signal ratio, because the time to signal ratio is proportional to the square root of the number of average. Third, I suggest to measure the pulsed EM signal by a proper design. In passing, there is a very interesting characteristic time constant, namely 133 nanosecond, which is determined by treating the receiver as a standard dipole antenna. And this time constant appear in the diagram, in the experimental result. I can show you. From this diagram, you can see that the time constant or period 133 nanosecond appear are associated with that oscillation of the detected voltage crossing the resistor. The fourth suggestion is to shield the battery and the switch, as shown in this diagram on the left-hand side. In this way, we can eliminate any possible EM transmission from the battery and the switch assumed by veritasium, while still allow the EM induction occur. Of course, we can use a longer cylinder to share the longer part of the battery side. In this case, both the possible EM radiation and EM induction effect will be reduced or completely eliminated. In this way, we should be able to detect more interesting results to figure out what's going on within the time scale less than 3.3 nanosecond. Here, I would also mention some new measurement based on the correct time scale. Ideally, the emitted and received signal can be described by the step functions, but in real life, we are obliged to use this so-called the displacement at half height of the signal. Here, the amplitude of the emitted signal and received signal are normalized so that the displacement appear at the half height of this normalized amplitude can be accurately determined. Apply this method to the experimental result obtained by veritasium, then we can measure that the displacement or time delay is 13.4 nanosecond. That is how you can measure the time delay between the voltage generated at the battery side and the response from the measured voltage across the resistor. So that time delay is 13.4 nanosecond. Here, I've also mentioned that Veritasian used a testimonial from retired printed circuit board designer to justify his claim that energy can be transported from the battery while fed to the electro appliance. But unfortunately, in physics, since Galileo's time, a theory can never be justified by using no matter how many testimonials you could find. Any theoretical claim must be backed by experiment rather than consensus. Here, I would like to emphasize my point that the photons associated with the EM wave from the battery cannot create the electrical current across the bulb. Therefore, many people should be aware of the Veritasian's mistakes about electricity. Thank you for watching this video. If you have any comment, please let me know. I will continue to make interesting video about electricity. See you next time. Goodbye.